Hello and welcome, my dear student. So in this lecture series, I am going to solve some of the interesting and challenging numerical problem from the physics book Pathfinder. So let us start with the session. So here there is a disk placed on a large horizontal floor is connected from a vertical cylinder. So this is the cylinder and I connect a disk. This is the disk. Okay. So on a floor. So this is the horizontal plane. So cylinder having a radius r fixed on the floor with the help of a light inextensible cord of length L. So this is the cord whose length is L, and you project this disk with a velocity in this direction. Okay, so disk is given a velocity u parallel to the floor and perpendicular to the cord. So in this direction you project it. So ultimately what happens, the disk will try to rotate about this. Okay, about this it will rotate. Okay, ultimately you are asked to calculate how long will the disk will slide on the floor before it hits the cylinder. Okay, now in the entire floor, so there is a friction coefficient of friction mu is given. So ultimately because of this mu, the particle will slow down. Okay, now try to visualize the entire figure from the top view, so that will give the better understanding. So let us say this is the cylinder part. This is the cylinder part. Okay, so this is the string that has been attached with the cylinder. Now this end is given a velocity. Let us say this is the velocity v is given. Okay, in time dt, this string has moved by this much distance, that is v times dt. This is the v dt distance traveled by the string, or I can say the disk. Now during that time, so this is the portion of the string that has been wrapped. Okay, so let us say this angle is d theta. So d theta portion of the string is being wrapped, and under that situation, this is the new position of the string. Okay, so once the string is being given a horizontal push, so it will wrap around the cylinder. It will wrap around the cylinder. So let us say this angle is also d theta, and this is the length of the string, that is initially L. Initially this is L. So can I say that dl length, that means the portion of the string that has been attached with the cylinder. So this portion is, let us say that is the dl number. So that is the portion of the string which has been wrapped. So dl is equals to r times d theta. What is r? R is the radius of the cylinder. So dl becomes r times d theta. Now what is d theta then? D theta should be equals to dl by r. Okay, dl by r. Now this distance v times dt is the distance linear movement by the disk itself. Okay, and that is equals to also this v dt is equals to L times d theta. That is equals to L times d theta. So corresponding to that, what you can write that L dt equals to v, L d theta equals to v times dt, and if I substitute this number, so d theta is equals to L dl by L, so that it should be L into dl by r, this much. So r and v all are constant numbers. Okay, so that means what I am getting, that v dt, that is our dl number. V dt is equals to our dl number. So ultimately what I am getting, that dx, if I say this v dt, let us say I am saying dx number. Okay, v dt is our dx number. So dx is equals to our L d theta. Okay, dx is our L d theta. Now dx should be equals to L d theta, and if I substitute the value of d theta, so that d theta is L into dl by r, this much number. Okay, so ultimately what I am getting, that r times dx, that should be equals to L times dl, L times dl. Okay, now initially what I can say, the initial length of the string is L, final length is 0. Okay, final length is 0. So once the entire string is being wrapped, now what is the x number? So x number, when the length is L, then there is no portion of the string is being wrapped. So that means this linear elongation is 0. So that x is 0, and finally this is the x. If I do the integration, so what I am getting, that r into x should be equals to L square by 2. Okay, now here one thing is negative, another thing is positive. So if I take the d theta dl, so dl is decreasing. dl is decreasing and x is increasing. So you can put a negative sign to adjust this answer as positive one. So ultimately what I'm getting that x number should be equals to our L square by 2r. So what is x? X is the linear distance traveled by the disk. Okay. So dx is the displacement of the disk and that is equals to L square by 2r number. Okay. Now the particle will travel L square by 2r number. So that means the disk is traveling the L square by 2r number before hitting the cylinder. Before hitting the cylinder. So ultimately the total distance traveled by the particle is L square by 2r. But under that situation, so since the floor is offering a frictional force, so because of that, it will be retarded. So what is the retardation? A should be equals to minus mu times g. That is the retardation of the disk. So now initial speed of the block disk is u. Initial it is disk is u. Retardation is mu g and distance traveled is s is equals to, can I write L square by 2r? Okay. So if I put this variable, so and apply the equation s equals to ut plus half at square to calculate how much amount of time it will require to finally touch the cylinder again. Okay, so I am using this s equals to ut plus half at square equation by putting all those values. So on simplification, what I am getting that L square by 2r, that is s number, should be equal to u into t minus half at square means mu g into t square by 2. Okay, so that gives a quadratic in t. So once I solve this, so ultimately what I am getting, the quadratic expanded in the form of t should be equals to u by mu g plus minus root of u square by mu square g square minus L square divided by mu g r square. L square divided by mu g r square. Okay, that is the final expression of the t that I am getting. Now, here you have to conclude between the sign plus minus. So particle will stop. See, if I say the one, so this is the cylinder and here I am putting this disk in this direction with the velocity of u. So because the retardation created in this direction, that is equals to a equals to minus mu g. So eventually the particle will stop, that is v will be 0. After what time? V should be equal to u minus a t number. So corresponding to that t should be equals to u by mu g. So after u by mu g time, the particle will eventually be stopped. That means whatever the t number that I am getting out of this equation, that should be less than u by mu g time. Okay, so less than means you should consider only the negative. So there is no positive sign. So ultimately what I can conclude that final answer will be equals to u by mu g, t should be equals to u by mu g minus under root of this number. Okay, so that will be your number. So this is only possible. This solution is only possible, can I say, when this discriminant part is the discriminant part, that part should be greater than 0. That discriminant part should be greater than 0. So that will imply the condition on the u. What is the initial speed? So if I closely look at the discriminant part, so discriminant part means it should be positive number. That means what you can say that u square by mu square g square minus L square divided by mu g into r square, that should be greater than 0. That should be greater than or equals to 0. Now once I solve this, so ultimately it will give the value as u should be greater than or equals to L into under root of mu g by r. Okay, so this is the condition. That means the u should be projected velocity should be more than this number, then only it will hit. Then only it will hit. Now if u is less than that number, if u is less than L into under root of mu g by r, so this is mu g by r. If L is less, u is less than that number, so block will come to rest before hitting the cylinder. In this situation, the block will come to rest before hitting the cylinder, and the time for that should be equals to t should be equals to then u by mu g. After this much amount of time, it will be stopped. But in this situation, the particle cannot be hit the cylinder. So this cannot hit the cylinder. So hope you understand this. Thanks for watching the video. If you like it, please subscribe my channel.